Okay, so in this video, I want to talk about training validation test splits of datasets. So here's basically how it works. You usually would start with a whole dataset, and all the rows in that dataset would be the same as far as you're concerned. Then you would randomly split the dataset into a training, a validation, and a test set. So the training set is what you use to fit a model. So essentially, this is where the model comes from. So for example, if you're fitting a logistic regression, you would basically minimize the cost that we had for the logistic regression on just the training set. You would ignore the validation and test set, and that is how you would get the model. So by the model, I mean basically like the coefficients, like the A0, the A1, the A2, and so on. Okay. Now, once you have the model, if you think you're done, you would just take the test set and you would test the model on that. So this is where you would get the performance. So for example, you would get the correct classification rate here. Now, the reason we have the test set is that if you're just looking at the training set, you are risking overfitting. So what that means is that the model would predict the right things for data in the training set, but it would not predict the right things for data that you get once you're done. So basically on new data. So the test set basically represents new data. The reason it can represent new data is that you're not looking at the test set, you're setting it aside when you're fitting the model. Okay, so that means that hopefully the test set would look just like new data as far as the model is concerned. Now, a lot of the time that would not be true because new data kind of by definition would be created once you're done training the models. Maybe something changed in the world, and a lot of the time that would be an issue, but at the very least, you would not obviously be overfitting. So an example of overfitting where the test set is involved would be saying, okay, I'll train my model, so fit my model, so find A0, A1, A2 that fit the training set the best, and then I'll try to say, well, how well am I doing? Well, how well am I predicting on the training set? And you might be over-optimistic there. So the performance that you get on the training set would not be representative of what you would get if you actually tried the model start predicting using the model for new data. So where does the validation set come in? It comes in when you want to select which model you want to use on new data. So let's say that you have two models in mind. So you have model 1, but you also have model 2. So maybe model 2, like it would be just like a different A0, A1, A2, right? So it would be A0 and it would be A1 and it would be A2, and maybe you have a third coefficient, so you would also have A3, and we'll denote those with primes. So how do we know which of model 1 and model 2 to use? Well, we cannot look at how well model 1 and model 2 predict data in the training set, because it might be that model 2 just predicts better because it overfit better on the training set, not because it would genuinely make better predictions on new data. You also cannot just say, oh, I'll just try model 1 and model 2 on the test set. The reason you can't do that is that if you do that and you select the model that does better on the test set, well, then you'll again be over-optimistic as far as how well you'll do on new data if you just look at the performance on the training set, on the test set, sorry. Why? Well, because you're picking the model that specifically works the best on your test set, not on new data in general. So that would be kind of like overfitting on the test set. So what you do is you say, oh, I'll look at the validation set. The validation set so far looked just like the test set. We also did not touch it when we were fitting the models. Now, if we look at the performance on the validation set, so that would be here, and that would also be here. So this would be the performance here and the performance here. Well, we'll get some kind of estimate of how model 1 and model 2 would do on new data. Based on that, you can select which of model 1 or model 2 you prefer. Once you've made the final decision and said, okay, I'm done developing my models, I selected the best one, that's what I'm going to use. Then you can go to the test set, which hopefully you have not touched at all up until that point, and estimate your performance on new data by computing your performance on the test set.